Thanks for having me here today. Before getting into the weeds, let's just share a definition, because everyone is speaking right now about AI agents. So I'm pretty sure that almost everybody of you has a clear definition about what an AI agent here is, but let me give you one, okay? I've been working on conversational AI before generative AI, even with intent-based systems. Then generative AI came up. And so what's an AI agent? There are many definitions. I'd like to say it's an entity, a basic piece of software capable to take also some actions and decisions, which is something more in front of or compared to a generative AI system. So basically, normally an AI agent has some kind of agency. Normally it's made of a generative AI LLM or multiple of them, basically to have natural language understanding capabilities. On top of that, there is almost always memories to provide context, and most important, some kind of tools to take some actions, okay? So to call external API, maybe via MCP or via other protocols, but basically perform some actions. So that comes, of course, with a lot of opportunities on one side, but some risk on the other side, which leads often to the matter of trust. So how we can build trustworthy AI agents, that's a key point. So after this insight, the agenda for today, I will provide you a quick introduction about what we are doing at the Linux Foundation AI and Data Voice Interoperability teams. So these kind of multi-agent protocols called open floor protocol, a few use cases. Beacon Forge, it's a playground that you can use. I will share everything. Then I will move to how to use potentially multi-agent capabilities to mitigate hallucinations with an empirical example and empirical experiments, sorry, that we took already more than 1 year ago. What we have in our roadmap for the future, for the floor, and how you can get involved if you're interested. I'd like to share everything. I'm doing 2 or 3 jobs right now, but I'm here today because mainly of the voice interoperability project. And so I will share a lot of QR codes in my presentation. So if you're interested, please have your smartphone ready to grab and to scan them. There will be GitHub repositories, there will be papers, and so on. A bit of history about the project. The project started before COVID at MIT. It was about, the idea was about having voice to behave like the web, very generic idea, but then we came up with the idea of, okay, let's build some multi-agent capabilities, which by the way is nothing new. I was in Oxford last year, and there is a very good professor there teaching multi-agents, and there are many eminent persons that can teach us about multi-agent. But here the idea was to build something totally vendor-independent. So we created this team, this no-profit organization, and we renamed the project Open Floor Protocol just a few months ago. You can find this paper on archive. It could explain you the basics behind the specifications. It's totally accessible, and it's dated already to 2024. So feel free to download that. What you see here, it's a list of the main contributors to the project. I'd just like to thank all of them. It's not easy, as you can imagine, to come up with the vendor-independent protocols. Sometimes we have our internal discussions how to do things, but I think we did our job with the version 1.0 released more or less 1 year ago of the open floor. So why we thought a few years ago, actually, before, let me say, the hype of AI agents, nobody was talking about AI agents 3 or 4 years ago, that multi-AI agents interoperability is important. Well, there are so many AI agents now available. Before that, let me say, we call them, maybe not incorrectly, but chatbot, voice bots. So we had tons of them, lots of different frameworks. Every chatbot, voice bot is built with different technologies. They don't talk each other, or it's very difficult to do that. They are run by many organizations with different approach. So it's tough to have different AI agents to talk each other. There are frameworks now that can do that, but again, you are stick to that kind of framework. So for the purpose of scalability and openness, we started to think about this interoperability protocol to have multi-agent capabilities. So basically, what the open floor is, nothing fancy. It's a set of JSON standard messages that you can use to provide the capability of an agent and to have agents to interact with each other. Okay? Inside the JSON API, there is the possibility to use natural language to provide utterance, whisper, and other protocol specification that you can read about. And most important, it's totally, again, vendor independent. You can have a look at the specification on this GitHub repo, if you like. Here, instead, you can find a sandbox usable to play with the API. I don't have time now. Normally, I open my Postman and I play with the API during the presentations, but no time now, so feel free to have a look at that. If you download that Python framework, because it's written in Python, you will have a framework based on OpenFloor where you can try the API. So there is a dispatcher that is going to take care of the user message and route the messages to 3 agents. Pete, a general purpose agent. Athena is an agent specialized in books and authors. And there is Zeus that is going to call some external API to get weather forecast. Again, nothing too complex, but just to have a look and to play with the specifications. So that's the basic about the vendor-independent multi-agent capability. More or less 1.5 years ago, me and Deborah, the project manager of voice interoperability, we were wondering, okay, we have this. Could it be useful also to potentially mitigate some risk? For example, the hallucinations. So hallucinations are incorrect information and response that normally AI agents provide, but they provide that in a confident tone, so they are quite subtle. Even more subtle are prompt injections techniques, normally invisible to the user, to the human. So the question was, okay, what if we try to place multi-agent in a chain and we try to measure if we can mitigate the hallucination? So we did this experiment. We crafted more than 300 different prompts to generate hallucinations. And we had a chain of three agents, okay? A front-end agent doing some research and providing the first answer. The second-level agent purpose was to detect potential hallucination markers. And then the third-level agent was trying to further mitigate the hallucinations. And then the LLM as a judge, somebody mentioned LLM as a judge this morning, is used to measure the hallucination level. At the time of writing the paper, there was not much about hallucination KPI, so we crafted a formula that you will find in the paper. It measures a total hallucination score. I don't have time now to deal with that, but the important thing is that the less is the total hallucination score, the better the performance, because it means that we were able to mitigate the hallucinations. So the front-end agent is the blue line, orange is the second, and green is what came up after the third-level agent. And yeah, we got quite a significant hallucinations hallucination reduction, more than 90% measured. Of course, it's an empirical experiment without so many humans in the loop and with some limits, but it provides just an idea about what we could do at that time with 3 agents properly set up. Of course, the paper is on archive, it's published. Feel free to have a look at that and send me any comments. It would be much appreciated. What we have in our plan, we started to work on the specification about the idea to have these agents machine to machine to collaborate each other to solve complex problems. Machine to machine communications is growing so fast, so why not to have multiple agents with some humans or maybe without sometimes to collaborate each other to solve complex problems. So we engineered this concept of floor. The floor is a shared conversational space where agents can be invited, so the floor can be granted, they can be, there can be a revoke for some agent. There is also a security layer to manage everything, but basically the idea here is to have this shared conversational space with some specification how to manage everything. There are a couple of implementations that you can access to, totally free on GitHub. One is mine, the other is from Casbah, one of the contributors, which recently released a CLI to try that. Let me share with you a very quick video where you can see now an example of what's going on. This is an example of a supply chain use case. I have a similar example in the traveling. So in the supply chain, in this case, we have a critical situation. In the specification, there is the convener, which is going to orchestrate and invite agent. There is a human agent with a problem in this case. And then we have a logistic agent, demand agent, and a procurement agent with different roles and capabilities. They are going to collaborate in this shared conversational space, so in the floor. And there is also a sentinel agent to taking care of the security, or some level of security. So I will play the video if the audio is going on, and get back to you in a minute.
Milan Warehouse reports critical stock shortage for component SKU 4782. Demand surged 40% this week. Immediate action required to prevent production stoppage.
Critical shortage confirmed. Invoking procurement agent, logistics agent, and demand forecasting agent. Floor is open.
Real-time data shows demand spike from early automotive client launch. Trend projected for 8 weeks minimum. Recommend 35% increase forecast for SKU 4782 next 2 months.
Germany supplier, 5,000 units in 7 days. Poland, 3,000 units in 48 hours, 12% premium, proposing split order strategy.
Poland requires dedicated transport, 36 hours delivery, 850 euros. Germany via rail for sustainability.
Coverage ratio restored to safety levels. Forecast model updated. Automated alerts activated on 15 correlated SKUs.
Approved. Proceed immediately. Real-time tracking and post-mortem Friday close of business.
Operations confirmed. Orders activated. Post-mortem Friday 2 p.m. Floor closed.
That's okay. So that was an example. Everything was made with totally open source voice capabilities and LLM, of course. I don't know how 2 minutes, so I will be very quick. So the benefit of the floor that you saw and the multi-agent capabilities, vendor-independent, is basically to solve complex problems. They can also help in hallucination mitigations. And yeah, there is another paper. I don't have time now, but we did a similar experiment with multi-agents to try mitigating the prompt injections. The result was okay. Not that performing like a hallucination. Prompt injection is more difficult to detect and to mitigate, but we got some result. Well, contribution are welcome. Our voice interoperability team is made mainly by European and American guys. You are free to join us. We meet twice a week. It's free, it's open to join. If you want to contribute to the specification or just to try that, please feel free to have a look. And of course, contact me here, or I will be here around to speak with all of you. Thanks so much.